3, 2, 1.
Hit it. Experience 24 hours of head-to-head AWS sessions from around the world.
Mic check, 1, 2.
Jaws PANKRATION 2021. Up till down.
Good evening, everyone. Today, I will be sharing my experience of building a healthcare critical platform using AWS. During COVID, information was unavailable and was needed quickly, like beds, medicines, healthcare facilities, etc. We worked with non-government organizations and large volunteer groups. The focus of the platform was on information awareness. We knew it was going to be a large-scale deployment spanning the entire country. We had multiple stakeholders, from government officers, medical professionals, to the citizens themselves. We had a very small window within which to build a resilient system. Data entry was being done by non-technical people and had to be as simple as possible. Our requirements included the platform had to support regional languages and dialects. The data came in at different intervals and near real-time updates were expected. We had to support analytics for further improvement and to support government agencies. Data was already being requested by third-party systems all the time. Primarily, it had to be cost-effective as it was self-funded. The right answer is always a proven three-tier architecture, but it is not always the most effective or low overhead. We investigated other approaches as well. Low-code solutions like Bubble or Webflow could work, but we had little experience with those systems. We also thought of using an automation backend with a custom website like Integromat. WordPress is always on the table with plugins, but we did not want to go that route. So WordPress is always on the table with plugins, but we did not want to go that route. So before we move on to the final architecture, let's see what the outcome was first. So let's see what was the outcome that we built. We built a responsive single-page application on React.js for the front end. It supported more than 8 languages. It was in use by 90%. It was in use by more than 90% of the country, reaching 2 million visitors at peak. When it comes to metrics, our error rate was near zero for most of the deployment. Our maximum error rate was only 1.5% during the initial launch. When we talk about the cost, our cost was under $250 per month. And as you can see, we only spend money on data transfer. We were extracting data from PDF files, and we used Amazon Textract for it, which ended up taking some cost. So what did the architecture look like? Instead of using a traditional database, we stored all our data in JSON files on S3. These JSON files were fetched and cached by the front end, and UX processing was done by React.js. We deployed a fleet of Lambda to collect information from over 200 sources. So we deployed a fleet of Lambda to collect information from over 200 sources. Analytics data was stored in DynamoDB and served via API gateway. We had no moving parts to fail because of AWS. The origin databases from where we got data ranged from government websites, Google spreadsheets, Airtable, S3, MySQL connections, etc. We also built our own interface for specific use cases that provided data. All the data was fetched at regular intervals using a fleet of Lambda functions. It was normalized and stored in S3 for each city or region that the website could use directly for. All sort and search functionality was handled by the front end only. Analytics of clicks, search keywords was sent to a DynamoDB using API gateway. Third-party API clients use the same endpoint to fetch data. An aggregator Lambda processed snapshots and provided analytics information to stakeholders. API gateway deserves a special mention. It solved the problem of authentication and abuse out of the box. Usage plans ensured we were not used as a backend for other systems. As the output of the API was the same JSON, API gateway connected directly with S3 without glue code. In conclusion, we spent 1.5 months on development, with most of it being on UX. We reached 2 million visitors across the country in a short span of time. It did not cost a lot since we fell under the free tier. Our main cost was data transfer, which is CloudFront. We had zero downtime, which was very critical for our use case. DynamoDB was not in our critical path. All data was being served directly via CloudFront and S3. We used CDK to deploy fleets of Lambda as we got bigger. It kept our operational overhead very low. Let's talk about our learnings. Complex is not always good. Always think out of the box and apply your constraints. So always think out of the box and apply your constraints. We would probably use a traditional database if we had a lot of write paths. CloudWatch monitoring ensured we reacted quickly to Lambda failures. So CloudWatch monitoring ensured we reacted quickly to Lambda failures. We did not need any advanced monitoring because everything was handled by AWS. We consider this more as a DevOps success story rather than a development one. Thank you so much for your time. I'm reachable on email, LinkedIn, and I also blog on dev.to. I'll be more than happy to answer any questions and talk deeply about the architecture on a one-on-one basis. Thank you so much.
Music's loud and I'm feeling alright. It's slow motion, but it's just you and I. Yet the burn makes you feel so alive. And we live in the moment, so you can live in tonight. We're here now, let's party together. Let's live life, tonight is forever. We're here now, let's party together. Let's live life, tonight is forever. Let the rhythm move us, yeah baby, take it too far. You're at the center of my attention, yeah you got me so lost. I love the way that you move.